Hello, welcome back once again. Today we are going to look at group 1 elements of the periodic table. And when we look at group 1, we have a number of elements in the periodic table. However, we have already looked at their compounds in other groups, or when we're looking at compounds of other groups, compounds of those elements of other groups. For example, group 7, we looked at their compounds. We have group 6, we also looked at compounds of group 6. We have group 5, we also looked at compounds of group 5. And then we have 3, 2. Today we are on group 1. So when we look at group 1 elements, we can have it divided into two. We have group 1A elements of the periodic table, which is where we find we have lithium, we have sodium, we have potassium, we have cerium. And then when we look at group 2B of the periodic table, we see that we have copper, we have silver, and then we have gold as elements of group 1B. So when we look at these compounds of group 1A, we have already interacted with their compounds, or these elements of group 1A. For example, sodium, we have a number of compounds of sodium chloride, sodium nitrate, sodium sulfate, sodium dioxide, sodium peroxide, sodium thiosulfate. So we see that we have already looked at them, and we have already looked at their pharmacological uses. So that takes us to looking at group 1B elements. And our main interest is not on copper, but our interest is on silver nitrate or silver. So with silver, we need to know its atomic number. Atomic number of silver is 47. And then I hope we can write our electronic configuration of silver. So when we look at silver, we need to know the compounds that we have a pharmacological effect in the body. So that takes us to a compound of sulfur, and more specifically is silver nitrate. That is why today we have here silver nitrate. So we need to know how is silver nitrate prepared, that's the outline, and then after we have known how it is prepared, what are the chemical reactions of silver, and then what are the properties of silver, what are the uses of silver, and then we are going to look at pharmaceutical assay, or we can call it, pharmacological assay, qualitative analysis of our silver nitrate. So this is prepared. How it is prepared, we need this is prepared by dissolving a copper silver alloy in nitric acid. So we expect an alloy. An alloy is a compound that has two metals, or it has two or more metals. When metals combine together, or when metals form a compound, we call them alloys. So we need a copper silver alloy reacted with the nitric acid in the presence of heat. So in this specific reaction, maybe let us be counteracting with the second one. So this is copper, silver copper alloy is reacted with nitric acid. So when under the presence of heat, when we have this, we are going to see that we are forming two nitrates. That is for both the two metals that we have in the alloy. One is silver nitrate, and then the other one is our copper 2 nitrate. What you need to appreciate is copper has two valencies, or has two oxidation states. It has the oxidation state of 1, and then we also have the oxidation state of 2. So in this specific case, here we see that our copper here has used a valency of 1. That is why we see that all of them, there is no 2 in the middle or 1 bracket and put 2. But when we look at this specific compound, we see that this copper 1 has been oxidized to copper 2, giving us copper 2 nitrate. And then we have nitrogen monoxide and water. So we see that our main interest is silver nitrate, but we don't just stop here. If we stop here, we shall find a number of impurities, being one of it copper 2 nitrate, and then our nitrogen monoxide and water. So since we have not reached the end point, we have to continue. And how we continue, we are going to separate out silver. We are going to prepare silver alone as a metal. So that takes us to the second paragraph where they say, then purified. So whatever we have prepared, whatever we saw in the equation, we are going to purify it. And then how do we purify it? We are going to add hydrochloric acid in it. We know that when we are testing for the presence of chlorides or halogens, we use silver nitrate. And then for specifically chlorides, we find that silver nitrate reacts with chlorides to form silver chloride, which appears as a white precipitate. And this is the second equation, where we see that we have silver nitrate reacting with hydrochloric acid, giving us silver chloride. So silver chloride is a solid and it is a white precipitate, and then our nitric acid. But that is not enough. We see that we have not reached our target. So it requires us to continue. And how we continue, we have been told here that the latter is reduced with, we need a reducing agent. The precipitate that we have formed, we are going to reduce it with zinc, presence of zinc, and then silver freed of impurities is freed of impurities is gained, or is gained, let's say that. So when we come to this second equation or third equation, we see that silver chloride, which was formed, has been reduced with zinc. But zinc and this cannot happen alone. They are all precipitates or they are all solids. Find that silver chloride is a solid, zinc is a solid. So we need an acid or we need a liquid. And when we look at the two compounds, it is the acid that can dissolve them. Okay, so by doing that, we see that we have now got silver and we have freed it, or we can now precipitate it out. We can filter. Okay, let's say filter. This must be black, supposed to be black, so we remove this A. So we find that we form this black precipitate, which you can distill or we can filter, whereby our residue will have pure silver. So that silver we have not yet reached. Our main aim or product we need is silver nitrate. So it takes us to the fourth step, where we are now, actually in this slide that we are, which says the latter is reduced with zinc, and then the silver freed of impurities is again dissolved in nitric acid. Okay, so you find that after that, since our aim, we have now got the silver iron or metal, silver as a metal, so we need now silver nitrate. So we react the resultant residue with our silver nitrate, our nitric acid, to give us silver nitrate, nitrogen monoxide, and water. Okay, so we see that silver nitrate is treated with a small amount of water. We already saw in that chemical equation we have water in it. And when left standing, crystals are formed, meaning we expect our water to evaporate on standing. So by doing so, we are able to get our crystals of silver nitrate. The crystals are filtered off and rinsed with water. After we have got or received the crystals, we filter them off from that mixture, and then we rinse. While we are rinsing, we are making sure that the salt of silver nitrate doesn't have any other additives or does not have any other impurities. So that is briefly how we prepare silver nitrate. Method of preparation of silver nitrate. What you need to know: prepare it from an alloy, and that is silver or copper silver alloy. You react it with nitric acid and then form your two nitrates, that is for copper and then silver, where we shall have silver nitrate and then copper 2 nitrate. And then after that, you pick or collect. The main aim of the second equation is for you to precipitate out or to only have silver compound. and not have other impurities, exaggerated impurities, because copper as well will be there. So our main aim is not to prepare copper. That's why we have left out the copper. So by doing so, by precipitating out your silver, by zeroing out to one element that you want from this alloy, it requires you to add the acid. And by adding the acid, you form a precipitate, a solid. And that solid that you have formed, you're going to reduce it with zinc. And zinc cannot react in the presence or without an oxidizing agent, that is our sulfuric acid. So by doing so, you form those compounds that we talked about, where we form pure silver, and then zinc sulfate and HCl, that is hydrochloric acid or hydrogen chloride. And then we see that the silver we have formed, we have not yet reached the target of forming silver nitrate. So we shall require an acid that has a component of the nitrate, that has nitrate. That's why we see that we don't use hydrochloric acid here, because it would give us silver chloride instead, and yet our aim is on silver nitrate. So because of that, we shall form silver nitrate, nitrogen monoxide, and water. So let's look at properties of silver nitrate. It is composed of colorless transparent crystals in the form of plates or cylindrical crystals having a radiant crystalline in a fracture form. And then we see that it dissolves readily in water. This is another property. Find that it dissolves readily in water and sparingly in alcohol, meaning dissolves in water or soluble in water, and then insoluble or sparingly soluble in alcohol. And then you see that the crystals darken in light. When you expose silver nitrate to light, you find that they are going to turn black, okay, meaning oxidation has taken place. And then we see that our silver compounds, we shall end up preparing silver as a metal when it is exposed to light. So this tells us that when we are storing, when we reach the slide that talks about storage of silver nitrate, it means that we need to protect it from light. So most of the compounds that we protect from light, we store them in amber bottles. Amber bottles, I can call it brown bottle, so that it prevents it from light rays. For example, when we look at opaque objects, okay, in other words, we have to store it in an opaque object. We know that opaque does not allow light to pass through them. However, the transparent ones will allow light to pass through them. And when we store them in the transparent one, you'll find that the light will pass through, and then the crystals will darken on storage. And it may be of a disadvantage to us, to you who has stored them. So after knowing the properties, dissolving in water, dissolving in sparing soluble in alcohol, the color that they have talked about, the color of the component, and then its sensitivity to light, there is need for us to know how we can identify the ions that we have in this compound. When we look at this compound, we have two ions, by the way. We have the silver ions, and then we have the nitrate ions. So when we looked at group 5 of the periodic table, we looked at nitrate or nitrogen and its compounds. So for nitrates, we have a specific reagent for testing for nitrates. So when we are dealing with this test, we may only interact with the test for silver, because I am assuming that with the nitrates we already know, where we say we shall use diphenylamine, where we expect a blue solution to be formed, confirming a presence of nitrogen or nitrogen component or nitrates in a specific solution. So here we are going to deal with silver. However, when you're asked to describe identification tests, you have to give us you have to identify how many ions, how many cations and anions do I have in this compound. And after you have identified the cations and anion, carry out different tests on the cation, and then carry out a test on the anion. So the preparation is identified by reaction of silver ions. Like as I've said, we are focusing on silver ions. But when we look at nitrate, we also have ways of identifying the anion. Okay, so here we are identifying the cation, whereby we have to add hydrochloric acid. It is salts are added to, or it is salts. Apart from hydrochloric acid, we can have a salt of chloride. A salt of chloride, you can have potassium chloride, you can have magnesium chloride, we can have sodium chloride. Common table salt is sodium chloride. So we can have sodium chloride solution, and then we add silver nitrate. When we add that, we expect to see a white precipitate. This is our observation. We expect to see a white precipitate. A white precipitate. This should be, let me put it in red. A white precipitate of precipitate. Are we safe? Alright, so we can say we have a white precipitate of silver chloride. It's even right here. Alright, okay. So we have a white silver chloride precipitate is then separated or is formed, and when it is formed, we have to confirm further by dissolving it in nitric acid as well as ammonia solution. So when it is insoluble in nitric acid, we shall confirm that the silver ions are present, and then when it is soluble in ammonia, of course we expect the precipitate formed to dissolve in ammonia solution, and since it dissolves in ammonia solution, we expect to get a complex. So this is the equation of reaction of what happens, where we say that silver nitrate is reacted with hydrochloric acid to give us silver chloride, which is a white precipitate. And this white precipitate, when we add it, or when we add nitric acid to the component of our silver nitrate formed, we find that there will be no observable change. That is why they are saying it is insoluble in nitric acid. But when we add that component of our precipitate, when we sample out the white precipitate and we add ammonium hydroxide into the precipitate, we expect this white precipitate to turn to a colorless solution, meaning it completely dissolves in ammonium nitrate. And this is our equation of reaction showing how it dissolves in our ammonium nitrate. Okay, so that is one of the tests we use, or that is one of the tests we have to carry out, and then the equations of reaction. So to confirm silver ions in its source, their reduction to silver is explained by formation of a silver mirror. So when we looked at carbonyl compounds or aldehydes, so we say that carbonyl compounds are divided into two. We have aldehydes and ketones. So we should know how we distinguish aldehydes from ketones. Okay, so we see that aldehydes are oxidized or undergo oxidation type of reaction. However, with ketones, they are not oxidized. And since they do not undergo oxidation, they will not have our silver will not have any effect on our ketones, or we can say alkanones. We can either call them ketones or alkanones. And then for aldehydes, we can also call them alkanals with al as a suffix, and then we can also call them aldehydes. So the first aldehyde that we have is called formaldehyde. So aldehydes react with what we call ammoniacal silver nitrate. When we look at a confirmatory test for aldehydes, we use ammoniacal silver nitrate, meaning we have silver nitrate in the presence of ammonia solution, or we have dissolved silver nitrate in ammonia solution, giving us what we call ammoniacal silver nitrate. So when this chemical reaction takes place, we expect to form a silver mirror. On heating, you're going to mix. We find that this aldehyde get oxidized to carboxylic acids, and then after they have gotten oxidized to carboxylic acids, silver is going to get reduced, giving us silver metals. And then a silver metal is observed as black. Okay, and then when we heat that specific resultant solution, we see that this silver or this gray precipitate, other books give us tell us it is a gray precipitate, we find that it is going to get deposited at the walls of the test tube. So that deposition at the wall on heating is what we call a silver mirror. So after some time, we say a deposit of a silver is formed in form of mirror appears at the vessel. Anything that you use, that you're going to use in carrying out this test, is called a vessel. So you can be asked to describe oxidizing properties of silver nitrate. The oxidizing properties of silver nitrate is seen when silver nitrate is able to oxidize carbonyl compounds. And to be more specific, it is able to oxidize aldehydes to carboxylic acids. Okay, so that means it is showing it is oxidizing property. It is able to oxidize other compounds and then itself gets reduced. So let's see equation of reaction. So formation of you see that silver nitrate reacting with ammonia to give us this, and then ammonium nitrate and water. So this is a formation of ammonia equals silver nitrate. Okay, and then of course in your combination you can say silver nitrate in the presence of ammonium hydroxide. So this resultant solution, this is what is able to oxidize our aldehyde. This is our aldehyde. This is a functional group. This should be one hydrogen. So we see that we have a carbon having two bonds, double bond to oxygen, and then it's two single bonds on hydrogen, giving us this plus silver, which is a black, and this black is the one which is going to get deposited in the mirror. I mean in the walls of the vessel or walls of the test tube, giving us that mirror-like image. Okay, like a real mirror. You can see yourself through it. And carboxylic acid. So it oxidizes aldehydes to carboxylic acids. And it is also a confirmatory test for the presence of silver. So you can use the first experiment for identifying or suspecting the presence of silver, and then you confirm when we react it with formaldehyde or when we react it with methanol. That is the first aldehyde when it reacts with our ammonia equals silver nitrate. Okay, so I hope I'm speaking to somebody. What I'm meaning is I hope you understand. In case you don't get anything, please put in the comment section below. Thank you. So the reaction of silver cations with potassium chromate yields a reddish brown. This is another chemical reaction. Reaction of silver cations with potassium dichromate. It yields a reddish brown silver chromate precipitate. And then the precipitate is soluble in nitric acid, and it is also soluble in ammonium hydroxide and sparingly soluble in acetic acid. And that takes us to how these chemical reactions look like. So we see that silver nitrate reacting with potassium chromate. When we look at this chemical reaction, the first element here takes the last element or compound this time. The last takes the first. If the Bible says the first will be the last and the last shall be the first. Okay, I hope I don't offend the non-Christians by saying that. But that's what the Bible says. We are not sure what the Quran says and the rest. But that is what it says. And we are not also trying to blaspheme the Bible by using it in here. It is just to remind ourselves on how compounds are formed. Thank you. So we form silver chromate and then potassium nitrate. So the nitrate ion is determined, like I was saying earlier on. This is now when we are identifying the presence of the nitrate ion. So how we identify it, we use diphenylamine and we expect to observe a blue solution or a blue color. So by the end of the whole stuff or the whole of this, we see that we have managed, or we have been in position to identify or carry out tests for two ions, the nitrate ions and then the silver ions. Silver ions, we have around three reagents we use. One is when we use concentrated hydrochloric acid, when we use hydrochloric acid. And we don't stop there when we use hydrochloric acid. To the resultant precipitate formed, we add nitric acid and then also we also add ammonium hydroxide or ammonia solution. So when we look at ammonia solution, it dissolves the precipitate form, that is the white precipitate of silver chloride, and we give the equation of reaction. And then when we look at nitric acid, they have told us it is insoluble. So we are not going to see any observable change, and that is why we didn't have equation for it. The second reagent we have used is formaldehyde. When we react silver nitrate, ammonia equals silver nitrate, in the presence of analdehyde, we expect it to oxidize analdehyde to a carboxylic acid. So when it is oxidized, it gets reduced, and when it itself gets reduced, we form a gray precipitate or a black precipitate. So gray, this precipitate, some people see it as black, others see it as gray. So it depends on the color sites and the rest of the thing. But after that, on heating, we expect this black precipitate or this gray precipitate to deposit at the walls of the test tube. When it does that, it forms a mirror-like thing. It forms a mirror, and we call that mirror image, or a silver mirror. Sorry about that. We call it a silver mirror. And then the other compound or other reagent we use is potassium chromate. Potassium chromate reacts with our silver nitrate. We are still testing for silver ions, giving us silver chromate and then potassium nitrate. So when we observe a reddish brown precipitate, we shall conclude that silver ions confirmed present. So we have three reagents. When we are asked, or when examiner gives us a question asking us on how to identify the following ions, how to carry out identification tests of the following ions, you can either use potassium chromate, you can use formaldehyde, or you can also use HCl, that's hydrochloric acid or hydrogen chloride. You don't use all of them, okay? And then when we are asked to test for nitrate ions, we have been given something here on how we test. One of the reagent we also use here is diphenylamine, and then the other, we are going to see formation of a brown ring when we react our nitrate or the acid or the resultant solution. When we react it with sulfuric acid, we see that we require to react silver nitrate in the presence of sulfuric acid to form food or to give us silver sulfate and nitric acid. However, this nitric acid formed in solution, we are going to bend or slant our test tube. When we slant it, we add a quantity of, we add in drops concentrated sulfuric acid. We expect to observe a brown ring. A brown ring in the presence of iron 2 sulfate. We expect to observe a brown ring, and that brown ring, this is what happens in formation of the brown ring. The nitrate present reacts with this concentrated hydrochloric acid in the presence of iron 2 sulfate to give us iron 3 sulfate. This iron 3 sulfate, we find that we have oxidized iron 2 to iron 3, and then we have sodium monoxide and water. So the iron sulfate, more of the iron sulfate will combine with sodium nitrate. Nitrogen monoxide in solution. We see that this will be excess. So excess of it that has not gotten oxidized to iron 3 will furthermore react with nitrogen monoxide to give us the ring. And in case you shake this solution, you will have a brown solution instead. You will miss to see the ring. Some people actually fail to see that ring. Yeah? All right, so that takes us to what we call pharmaceutical assay. With the assay, what you need to know the method of assay. You need to know the reagents used. You need to know the end point, and then in case that specific assay has indicator, you also need to know about it. Not all assay or methods of titration require indicator. Another word for assay, we can call it titration in a layman's understanding. Not layman, but in a simpler way that all of us can understand. A good quality of the preparation is determined by absence of heavy metals, that is lead, copper, and bismuth. The content of the preparation is determined by what we call Volhard method of precipitation. So what happens there? We see that we have silver nitrate in the presence of what we call ammonium. We are going to react silver nitrate with our ammonium thionate to give us this compound. The first takes the last takes the first. And then after that, we see that the reactions further happen. Precipitation, meaning we expect to precipitate out some compounds. So we shall have ammoniacal solution of iron 2 sulfate, where we shall form a red precipitate, meaning we expect to have a red precipitate at the end. We expect to have our observation as the red precipitate. Okay, so that is the assay. We have the reagents. And then we have the method. We know the method. Here we find that we don't need there is no need for indicator. This specific method of assay happens without indicator. And since there is no need for indicator, we have not mentioned it, but we need to know the endpoint. And the endpoint is our red solution being formed. When a red solution is formed, you stop the titration. The titration stops there. All right, so that is it. And then we have uses. For uses, we have a number of them. We see that used in medicine for the catheterization for wounds and ulcer, and then it is catheterization is due to ability. This is they're explaining the first thing. It is ability of silver nitrate to coagulate proteins and transform them into insoluble compounds. In small amounts, silver nitrate has astringent and antipyretic properties. It can also be administered externally in erosions, that is ulcers, in 1 to 2% ointment. We need that ointment for erosion of ulcer. Okay, and then we have administered externally in erosion, and that is what we have just talked about. And then it is prescribed orally in form of 0.05 to 0.06% solution of gastric ulcer and chronic gastritis. And then we have storage. All silver salts are poisonous, so this is a method of storage. And we are kindly reminded that all silver salts are poisonous, thus must be locked up in a well-closed orange. Like what I said earlier on, we said it is sensitive to light, and because of that it turns to a black solution when it is exposed to light. This is light. So that must be locked up in a well-closed orange glass jars with glass toppers in a place protected from light. Okay, so you have questions to answer here. Okay, if you have been attentive, I believe we can answer this. Describe with equation preparation of silver nitrate, and then state properties of silver nitrate. Explain identification test of silver nitrate. Describe assay of silver nitrate. And then what are the uses of silver nitrate? If we are able to answer this, I give you some 5 minutes to answer that. And in case of any questions, please ask. All right, I want to thank you so much for listening, and keep loving Grapharm Academy, and subscribe for more videos like this. Every new